Hi everyone, we are from Group 9. We want to explain our project 2, that is one of the satellite in Malaysia, which is WGS 84. Our group member are Farah binti Farul Zaman, Nur Anis Munirah binti Muslim, Muhammad Tayak Bararoh, and Muhammad Idham bin Ibrahim. Okay, firstly, we want to explain about the coordinate conversion. What is coordinate system? Coordinate systems enable geographic datasets to use common locations for integrations. A coordinate system is a reference system used to represent the location of geographic features, imagery, and observations, such as Global Positioning System or GPS. This consists of enable geographic datasets or common locations for integrations, and the second is reference systems and represent geographic features, imagery, and observations such as Global Positioning System or GPS locations, and as well as framework measurements and geographic planimetric. And then, what are the types of the coordinate systems? There are three common types of geographic coordinate systems. First is the global or spherical coordinate systems, latitude, longitude. And the second common type is the projected coordinate systems or UTM. And the last is coordinate systems, framework or real-world locations. A global or spherical coordinate system such as latitude, longitude, these are often referred to as geographic coordinate systems. The other one is projected coordinate systems such as universal transverse Mercator or UTM, and coordinate systems both geographic and projected provide a framework for defining real-world locations. However, after defining the coordinate system that matches user's data, user may want to use in different coordinate systems. This is where transformations or conversions are useful. Transformations or conversions are required to convert data between different geographic coordinate systems or between different vertical coordinate systems. Unless user's data lines up, user will face difficulties and inaccuracies in any analysis and mapping that they've performed on the mismatched data. The UTM or the Universal Transverse Mercator, or known as UTM, is a system for assigning coordinates to numerous locations on the surface of the Earth. UTM, also based on cylindrical projection, focuses on emphasis on zone number, hemisphere, and easting and northing. Eastings are referenced from the central meridian of the east zone, and northings are from the equator, which were both in matters. UTM ignores altitude, and it identifies the Earth as a perfect ellipsoid and is represented in horizontal positions, which is identical to the traditional method of latitude and longitude. However, it varies in terms of global latitude or longitude, which divides the Earth into 60 zones and projects each to the plane as a basis for its coordinates. Each one of the zones is a different transverse Mercator projection that is slightly rotated to a different meridian. UTM zone numbers designate 60 degrees longitudinal strips extending from 80 degrees south latitude to 84 degrees north latitude. The projection from spheroid to a UTM coordinate is a very parameterization of transverse Mercator projection. However, the parameters may vary by nation, region, or the mapping range system. UTM is a conformal projection which displays small features in correct shape, and the scale appear the same in all directions. UTM coordinates are in meters, which makes it easier to make accurate calculations of short distance between points and the error is less than 0.04. UTM is a conformal projection Therefore, small features viewed by the correct shape and scale is the same in all directions. This could also means that all distance, directions, shapes, and areas are most likely to be accurate. Scale factor is 0.9996 at the central meridian and at most 1.0004 at the edge of the zones. UTM also commonly used in USGS topographic and map and digital elevation models or DEMS. Even though the distortion of the UTMR systems are small, they are too great for many accurate surveying. Besides that, zone boundaries are also considered as a problem in navigation because they follow arbitrary lines of longitude rather than boundaries between jurisdictions. What is the differences between the WGS and WGS 84? Firstly, about the WGS. WGS is common to use in cartography, geodesy, and satellite navigation including GPS. It is also associated with the EGM and WGM, as well as the current list of local datum transformation. While WGS84 is the latest version of WGS. However, it originally used the GRS80 reference ellipsoid, which is undergone a refinements in a later editions. The origin coordinate of WGS84 is supposed to be at the Earth's center of mass. The common inaccuracy is believed to be less than 2 centimeters. The WGS84 meridian of zero longitude is the IRS or IERS reference meridians 5.3 arc seconds or 102 meters east of the Greenwich meridian at the latitude of the Royal Observatory. The WGS84 datum surface is an oblate spheroid with equatorial radius A equals 6378137 meters at the equator and flattening F equals 1 per 29 h.2567 223563. Before the current one, WGS84 used the Earth Gravitational Model 2000H. This UID defines the nominal sea level surface by means of a spherical harmonics series of degree 360, which provides about 100 kilometers latitudinal resolution near the equator. WGS84 currently uses the World Magnetic Model 2020. The next regular update, WMM 2025, will occur in December 2024. In WGS84, it has 4 defining parameters which are the semi-major axis of the WGS84 ellipsoid, the flattening factor of the Earth, the nominal mean angular velocity of the Earth, and the last is the geocentric gravitational constant. UTM to WGS84 transformation. Latitude or longitude, easting or northing, or X or Y ways we uniquely identify a position on Earth and are also called coordinates. Furthermore, there are two coordinate systems named geographic coordinate and projected coordinate. The one of the example of geographic coordinate is WGS84 while projected at is UTM. A geographic coordinate systems use a spherical surface and a position is identified by its latitude and longitude. Latitude and longitude are angular units of measure and are denoted in degrees, minutes, and seconds or decimal degrees. The longitude values range between minus 180 to positive 180 degrees. Latitude values range between 19 degrees to minus 90 degrees. Meanwhile, for projected coordinate, specifically UTM, A location is identified with easting and northing, and the units are in meters. When we create a map, we project a sphere Earth onto a flat surface, and we use projected coordinate system to do this. The latitude and longitude are converted to x and y coordinates. During these transformations, the surface of the Earth is distorted. There is no perfect map projection, and one chooses a projection based on what distortion is acceptable for their purpose. Therefore, to convert from UTM to WGS84, we have to transform from easting and northing to latitude and longitude, respectively. After the transformation, latitude is identified by Y or northing and L longitude by easting. The formulas are as below.